So now we're at the end of 1.3. We've talked about all of the different parts of these radicals. Now we want to kind of lump them all together and look at a summary of them. So each one of these problems, the directions are to simplify the radical. You need to decide how you simplify them. Are you using just plain simplifying? Are you using adding and subtracting? Are you rationalizing the denominator? Those are your options. So let's take a look at number 2. Number 2, we have a square root of 44. Square root of 44, I can break that down. It has factors of 4 times 11, and 4 is a perfect square. If I didn't know that, you have the option still of doing 44. Well, I know that that's 4 times 11. If you didn't know 4 was a perfect square, you could do 2 times 2. The pair of 2's gets to come out of the radical, and the 11 has to stay inside. Same thing over here on the right. The square root of 4 is 2, and I get the square root of 11, which can't be broken down anymore. Number 3, when I look at this one, there's no adding and subtracting, but it does have a square root in the denominator, so I need to get rid of that square root in the denominator. The way I do that is by multiplying by 1, and my 1 is going to be in the form of whatever that denominator is. So I multiply by the square root of 3 over square root of 3. So on the top, I get 5 square root of 3. On the bottom, I get the square root of 3 times the square root of 3, which is the square root of 9. So I get 5 square root of 3 over the square root of 9 is 3, and nothing else reduces with that, and so I'm done. Number 4, I want to look at, this is a subtraction problem, so I want to remember that with subtraction, adding and subtracting, I have to have the radicals to be exactly the same. If they're not the same, then I can't add and subtract them. But I also need to realize that if they're not the same, I need to try to make them the same. And if I can make them the same, then I can add and subtract them. So I've got the square root of 20. Well, I can reduce that because 20 is the square root of 4 times the square root of 5. And we just talked about how the square root of 4 is a perfect square. So the square root of 4 is 2. So I have 2 square root of 5 for the square root of 20. Then I've got a minus 6 out here. And then I can break down the square root of 45. I know that 45 is 5 times 9. Well, I've got the square root of 5 and the square root of 9, so I've got minus 6. The square root of 5 is not a perfect square, but the square root of 9 is. The square root of 9 actually is 3, and all these things are multiplied. So I've got 6 times 3, which is 18 square root of 5, and I've got 2 square root of 5 minus that 18 square root of 5. Well, now the radicals are exactly the same. 2 square root of 5 minus 18 square root of 5 is going to give me 16 square root of 5 with a negative, because 2 minus 18, if I've got two things and I take away 18, I'm in the hole. I'm losing. I have a negative. Now let's take a look at a couple on the back here to just get a general idea. Those were the 3 ways that we are going to simplify these radicals. They're the only 3 ways that we're looking at up to this point. But when I go to the back here, I want to see what problems look like when they're a little bit more complicated than those 3. So number 13, I've got 8 square root of 5 over the square root of 10. Well, the square root of 10, again, is in the denominator, so I need to multiply by 1 and rationalize that denominator, get rid of the square root out of the bottom. And the 1 that I use is square root of 10 over the square root of 10, because that divides to give me 1, and I don't actually change the problem. So let's take a look at this now. I've got on top, I've got 8, and then inside the square roots, I've got 5 and 10. I'm going to multiply those together to give me a 50. On the bottom, I've got 10 times square root of 10 times the square root of 10 is the square root of 100. Well, that's not so bad on the bottom, because the square root of 100 is 10. On the top, I've got 8 times the square root of 50. Well, I want to see if I can reduce the square root of 50. Well, 50 is like having 2 quarters. And I know that a quarter, 25, is a perfect square. So I'm going to put the square root of 25 times the square root of 2. The square root of 25 is 5, and the square root of 2 is not a very nice number, so I've got that over 10. On top, I've still got 8 times 5, which is 40. And then I can reduce the 40 and the 10, because 10 goes into 10 once, and 10 goes into 44 times. So I end up with 4 square root of 2 for final answer. Do not reduce the 2 with the 10. That is not something that we can do. outside of the radical goes with outside of the radical, inside the radical goes with inside the radical. So there's a simplifying problem with rationalizing the denominator. That's a little bit tougher. Here's 14. 14, I've got 7 square root of 8 minus the square root of 200. Well, those radicals aren't the same. In order to add and subtract, they have to be the same. So I've got 7 square root of 8. I want to take that square root of 8 and see if I can break it down. I can break it down into a square root of 4 and a square root of 2. So a square root of 4 is 2, so I've got 7 times 2 with the square root of 2, and still, that's 14 square roots of 2. Now the square root of 200, I want to look at that one now. Square root of 200, I know that we just talked about the square root of 100 being 10, so I'm going to divide 200 by 100 and get 2. So the square root of 100, we literally just talked about, is 10. And I've got minus 10 square root of 2. I'm just going to rewrite it again so that it's with my 14 square root of 2. 14 square root of 2 minus 10 square root of 2. Radicals are the same. 14 minus 10 is 4 square roots of 2. It's like 14x minus 10x gives me 4x. Let's take a look at 17. We again are adding and subtracting, but we want to look to make these radicals the same. So I've got 10 square root of 3. Square root of 3 nothing breaks down in that one. The square root of 12, though, I can do as the 4 times the square root of 3. The 5 and the square root of 20, I can do the square root of 20 is the square root of 4 times the square root of 5. We had that one already. And then 2 times the square root of 125. The square root of 125, again, is like quarters. So I've got 25 I can do, the square root of 25. And then if I take a look at that 25 quarters, or how many quarters go into 125, $1.25 is 5 quarters, and so I can take 25 times 5 to get 125. Now going through and reducing these, this is the other way to do these. On the problem before this, we worked on just one radical and simplified it. This one we're looking at simplifying all the radicals at one time, but be careful if you choose this way in order to solve these. 10 square root of 3, nothing happens. 2 times the square root of 4, well, the square root of 4 is 2, so I've got 2 times 2, which is 4. 5 times the square root of 4, the square root of 4 is 2, so I have 5 times 2, which is 10. 2 times the square root of 25, the square root of 25 is 5, so I've got 2 times 5 again, which is still 10, times the square root of 5. So now I'm looking to combine radicals. I've got 10 square root of 3 minus 4 square root of 3. They have the same radicals. There's no other square root of 3. So 10 minus 4 is 6 square root of 3's. I've got a 10 square root of 5 minus 10 square root of 5. Well, square root of 5's can be added and subtracted together. When I do that, they actually go away, and I don't end up with any square root of 5 left. And so I just end up with 6 square root of 3 for a final answer here for 17. And then finally, let's take a look here at 21. Number 21, I've got 2 numbers outside of the radicals and 2 numbers inside the radicals. So outside I have 3 times 2, which is 6. Inside I have 14 times 6. Hey, calculator if you want to. Multiply 14 times 6. 6 times 4 is 24. 6, 7, 8. I've got the square root of 84. I'm going to break down that 84. And again, if you want to use the tree, that's fine if you don't know any perfect squares in there. I know that 84 is 4 times 21. 21 is 7 times 3. 4 is 2 times 2. Here's a pair of 2's. So that can come out of the radicals. So I've got the 6 that originally was there. The pair of 2's which come out of the radical. And then I've got 7 times 3 that are still stuck in here, which is 21. So 6 times 2 is 12, and then the square root of 21 finishes off my answer for this. Make sure you're looking at this worksheet, deciding between the 3 types of simplifying radicals.